Finding the half-life from a graph. Here we have a Geiger counter which is going to measure the activity in becquerels from a radioactive source over a time of 12 seconds. So we'll turn on the simulation, see what we get. Well, you can see that the activity of the radioactive source is actually decreasing over the 12 seconds. And that's because the number of radioactive nuclei in the sample is decreasing because the radioactive nuclei are decaying and becoming more stable. And this leaves less unstable radioactive nuclei, and thus is going to reduce the activity of the source. So how do we find the half-life of that radioactive source? Well, we do it by looking at the graph, and here's how we do it. So here we have the graph which we obtained a couple of seconds ago. Now, to find the half-life of the radioactive source, we look at the initial activity, and the initial activity is shown there ringed. It is 2000 becquerels, 2000 decays every second. Now, half of that is going to be 1000. So we go down to 1000 mark on the graph, and we go along till we touch the graph, and then we go back down to the time axis. And you can see from the arrows there that the time it takes to go down by 1/2 is 3 seconds. So therefore the time, or the half-life time, is going to be 3 seconds. We can do the same thing again by looking at 1000 and dropping down to half of that. Half of that is 500. And you can see that takes place over a time of 3 seconds. So once again, the half-life of this radioactive source from the graph can be found, and it's 3 seconds, which means every 3 seconds you're going to have half the unstable nuclear atoms decaying into stable atoms.